All right, the last thing we did, we covered section 6.1 and 6.2. Section 6.1 was adding and subtracting polynomials. Section 6.2 was multiplying polynomials. Today we're going to do the opposite. What's the opposite of multiplying polynomials? What's the opposite of multiplying called? Not division. Factoring. The opposite of multiplying polynomials is called factoring polynomials. Now, my guess is you've seen factoring before. In particular, I'm very convinced at some point in your life you learned how to factor numbers. So if I asked you to factor the number 24, what would you tell me? There's more than one correct answer. How can you factor 24? You can write it as 8 times 3. That's one correct answer. 24 is 8 times 3. Another correct answer is 6 times 4. Another correct answer? 24 times 1. That's a correct answer. It doesn't do you a whole heck of a lot of good, but it is a correct answer. 12 and 2. Any other ways to factor 24? How about 4 times 2 times 3? Is that 24? Mm-hmm. Yeah, so when I say factor, I don't mean you can only use 2 pieces. You can use more than 2 things. And so the most important one we would say is the most important factorization of 24 is 2 times 2 times 2 times 3, which we would write as 2 cubed times 3. Why is that the most important factorization of 24? Well, smallest, you got the right idea. It's not the simplest necessarily. But 2 and 3 are special numbers. What can you tell me about 2 and 3? You can't factor them anymore. They are known as, what's it called? Those are prime numbers. So that's called the prime factorization. Okay, so what we're going to do in this section is we're going to factor polynomials. To factor a polynomial, means to write it as a product of 2 or more polynomials. And I started by saying factoring is the opposite of multiplying, and here's what I mean by that. Here's what we did last time. I might give you x plus 3 times x minus 5. So I gave you 2 binomials, x plus 3 and x minus 5, and I asked you to multiply them together. And how would you multiply x plus 3 times x minus 5? You would do FOIL. So you would have x squared Okay, I'm going to write it out. Minus 5x plus 3x, which does give you a negative 2x. That's correct. Minus 15. So your final answer would be x squared minus 2x minus 15. What we're going to do today is completely the opposite. I'm going to start with x squared minus 2x minus 15, and you're going to have to tell me what 2 things do you multiply together to get that. And so your answer would be x plus 3 and x minus 5. We already know the answer for this one. X plus 3 and x minus 5. So that's what I mean by this is completely the opposite. The other day, we started with 2 binomials. We multiplied them together. We ended up with a trinomial. Today, we're going to do the opposite. We're going to start with the trinomial, and you have to tell me the 2 binomials that it came from. Okay? All right, so let's just try a few here. How about x squared minus x minus 12? What should happen if you start with a trinomial like this? A trinomial generally will factor into 2 binomials. So you kind of got to think about doing FOIL backward. Well, let's see. It's got to be x and x, right? Because when I do FOIL on the first, x times x will give me x squared. Okay? So now, how can I get 12 on the end? One possibility is I could use a 6. If I use 6, what number do I have to use over here? A 2. And one of them has to be positive and one of them has to be negative, doesn't it, to get negative 12? So now the question is, are 6 and 2 the right numbers? And I don't think so. Because if I were to do x, let's say we did x minus 6, x plus 2, I don't think that's going to work. Why not? Because it doesn't give you x in the middle, does it? This would give you x squared plus 2x minus 6x minus 12. You would get x squared minus 4x minus 12. So that's not quite the right answer. It's close. We got the x squared in front. We got the negative 12 on the end, but we didn't get the right number in the middle. So what that tells me is 6 and 2 is not the correct way to factor the number 12. So how else can you factor the number 12? 3 and 4, 4 and 3. Does it matter which one you put first? No. 4 and 3. It does absolutely matter which one is negative and which one is positive. Which one should be the negative one? The 4 should be negative, and the 3 has to be positive. So that was not the right answer. We'll cross that one out. And the nice thing about factoring is you can check your answer real easy. How do you check your answer? Just do FOIL and see if it works. So I'll do FOIL on that one real quickly just to check it. That would be x squared plus 3x minus 4x minus 12. That's x squared minus x minus 12. That is correct. Now, you said it makes a difference which one gets the minus and which one gets the plus. Why does it make a difference which one gets the minus and which one gets the plus? Because I needed to come up with negative x here in the middle. If I had done a plus 4 and a minus 3, what would I have ended up with in the middle? A positive x. It wouldn't have been quite the right answer, but it would have been close. All right, let's try another one. How about x squared plus 3x minus 18. Again, what I notice there is I'm starting with a trinomial, 3 pieces. If I start with a trinomial, the vast majority of the time, it's going to factor as 2 binomials. How can I get the x squared in front? Got to be x and x. And now I need to think. On the end, I need to end up with an 18. So I need 2 numbers that are going to multiply and give me a negative 18. But at the same time, what else needs to happen? How am I going to get that 3 in the middle? They need to add up to be 3. Correct. So notice that's what happened back here when we get the negative x. The 4 and the 3, they multiply to give you 12. Negative 4 and positive 3 add up to give negative 1. So I need 2 numbers that multiply to be negative 18 and add to be 3. Negative 3 and positive 6 is our guess. And I think that's correct. Try it. Foil it out. When you foil it out, you would get x squared plus 6x minus 3x minus 18. And that would be x squared plus 3x minus 18. That's the right answer. Questions on that one? All right, a couple more of these. X squared. For the most part, in this section, the numbers are going to be pretty small. And in this section, it will always be just x squared. There won't be a number out in front. Well, there will be in a minute, but we'll see what I mean by that. The next section will deal with what do you do if there's a different number out in front here? And those problems get quite a bit harder. Let's see, how about x squared minus 10x plus 24. Well, once again, we notice we have a trinomial. Trinomials generally factor as two binomials. How do we get the x squared in front? X and x. All right, now I need to come up with two numbers that will multiply to be 24 and add to be negative 10. Negative 6 and negative 4.
Oh, wait. No.
No?
Wait. Yeah, sorry. I was thinking. Yeah, that's right.
That's right? You sure? How are you sure that that's right?
What?
Why are you sure that that's right?
I looked at it wrong.
You looked at it wrong. Oh, well, how can I be sure that that's right? I can just FOIL it out and check it, right? So this one would be x squared minus 4x minus 6x plus 24. And that does work. That's x squared minus 10x plus 24. A lot of people will get this one wrong. Tell me what's wrong with this. A lot of people will tell me the correct answer should be x minus 12 times x plus 2. Correct. The problem is it's not negative 24, is it? What would that have? Well, I mean, if you FOIL it, you would get negative 24. Do you get the negative 10 in the middle? Yeah, and that's kind of the trap on that one. Sometimes you got to be very careful. Negative 12 and positive 2 will give me the negative 10 in the middle. But negative 12 times 2 gives me negative 24. So that one would be wrong. So watch out for that. That can happen sometimes. Sometimes it looks like different combinations can work, but they really can't. That one would not be correct. So watch out for that. It's a good idea to do a FOIL, check it out, make sure it's going to work. Do you need to write down your check and show me that you did it? No, I would hope at this point you could pretty much, with these problems, you could pretty much do FOIL in your head and check it. But I think it's a good idea to do that. All right, how about, let's see, one more of these. X squared plus 8x minus 12. How do you factor that one? This must be a hard one, because we're coming up with the answers quickly to all the other ones. Well, what are your choices? You could have x and x in the front. How can you factor 12? Your choices are, I heard somebody say you could have 6 and 2. You could have 4 and 3. Or you could have 12 and 1. I think those are the only choices. So it seems like it has to be 6 and 2. Why does it seem like it has to be 6 and 2? Because they're the only two that you can make add up to 8, right? 4 and 3 won't add up to 8. 12 and 1 won't add up to 8. So it seems like it has to be 6 and 2.
It's no solution because there's no way you can have a negative 12 and a positive 8.
Perfect. There's no way I can get a negative 12. So to get a negative 12, I'd have to have one positive and one negative, wouldn't I? But if I have one positive and one negative, am I going to get an 8 in the middle? No. I could get an 8 in the middle by doing a plus 6 and a plus 2. But then I don't get negative 12 on the end. What do I get on the end? Positive 12. All right. So we tried all the possibilities and none of them worked. So what do? It's not no solution, but you got the right idea. You can't do it. So what do you write when you cannot factor? Non-factorable would be okay. The correct word is prime. Just like you have prime numbers. We talked about prime numbers, 2 and 3 were prime numbers. You can have prime polynomials. Not every polynomial factors, just like not every number factors. And here's a good example. So our answer for that problem would be prime. It simply doesn't factor. Questions on that one? Okay, the other technique we're going to talk about for factoring is called greatest common term. And again, this is really the opposite of some multiplying that we did the other day. The other day, we might have taken something like 2x cubed and multiplied by 5x minus 6. How would you take 2x cubed and multiply by 5x minus 6? Distributive property. So this would be 10x to the 4th minus 12x cubed. So again, what we're going to do today is we're going to do it backward. I'm going to give you the 10x to the 4th minus 12x cubed, and I'm going to ask you to factor it. So one of the things you look for when you're factoring is you always look for something known as the greatest common term. What do we mean by greatest common term? What's common to both of them? So for example, here, this one, you would look at the numbers. You would see the numbers are, you got a 10 and a 12. What's common for a 10 and a 12? 2. So you factor out a 2. And then you notice you have x's in each term. This one you have an x to the 4th. This one you have an x cubed. So how many x's do they have in common? 3. So you factor out an x cubed. And then what's left over? Well, 2x cubed times what gives me the 5x, gives me the 10x to the 4th? A 5x. And then minus 2x cubed times what to get 12x cubed? 6. So again, it's really just the distributive property backward. Yep, we'll do another one. So we already kind of knew the answer for that one. How about if I gave you 18x to the 4th plus 24x squared? You start with the numbers. What do 18 and 24 have in common? Well, they have 2 in common, but we wouldn't use 2. Why not? Because it's not the biggest thing that they have in common. We always want the greatest thing they have in common. 6, I think. Because 6 times 3 would give me 18, and 6 times 4 would give me 24. So we would factor out a 6. The greatest for 10 and 12 was a 2, correct. Then you look at your x's. This one has an x to the 4th. That one has an x squared. So how many x's do they have in common? 2. So I write down x squared. And then I put a parenthesis. And now I just got to kind of fill in the blanks. 6x squared times what to get the 18x to the 4th back? 3x squared. Because 6 times 3 gives me the 18. X squared times x squared gets the x to the 4th. Plus 4. Because 6x squared times 4 gives 24x squared.
So you're not subtracting the exponents. You're kind of seeing how many is left over.
Yeah, but you really are subtracting them. You're actually right. Because here I started with 4, an exponent of 4. I factored out 2. 4 minus 2 is, there are 2 left. And on this one, I started with 2. I factored out 2. 2 minus 2 is 0. There's no x's left there. So you really can do it as subtraction. So in a sense on these problems, I think the x's are easier. I think it's the numbers that are harder to deal with. Finding the greatest common factor of the numbers sometimes can be more of a pain in the neck than the x's. All right, let's try another one. How about, what if we have more than one variable? I don't know. Somebody give me a nice number. Anybody got a number? 5. Okay. 5. X squared y cubed plus. Anybody got another number? I got one. 35 x to the 4th y squared. All right, so these ones aren't, these one in this case, the numbers aren't too hard. You look at 5 and 35. What do 5 and 35 have in common? 5. So I write down 5. Then I look at my powers. Here I have an x squared. Here I have an x to the 4th. So how many x's are common? 2 of them. So I write down x squared. And next I look at my y's. I get a y cubed and a y squared. How many y's are common? 2. So I write down y squared. I have 3 y's in this term, but only 2 of them in this term. So they have 2 of them in common. 2 y's.
So that's what I mean. So you're not subtracting.
Not yet, but I'm about to. Okay? So let's see. I have 5x squared y squared. I need to get 5x squared y cubed. So all I need is the 5 and the 5. Those already match up. On the x's, I started with 2. I took out 2. 2 minus 2 is 0, so I don't need any more x's. I started with 3 y's. I took out 2 y's. 3 minus 2 is 1, so I need the y to the 1 right there. Plus 5 times what to get to 35? 7. I started with 4 x's. I took away 2 x's. So I need 2 more x's there. And I started with 2 y's, but I took out 2 y's. So I don't need any more y's, do I? 2 minus 2 is 0. Questions on that one? All right, here's my last one. How about 12 x to the 5th minus 6x cubed. What do they have common? 6. How many x's are in common? 3. So 6 x cubed. What's left over? 2x squared minus 1. Very good. And many people will forget that minus 1. Where did that minus 1 come from? From the 6x cubed. Okay. The 2x squared, that one's pretty easy. 6 times 2 gives me the 12. X squared times x cubed gives me x to the 5th. And a lot of people will think, well, the 6x cubed is all gone. But what you really need to think about is 6x cubed times what is going to give me the 6x cubed back. Just because the entire thing factored out doesn't mean it's gone. There's always got its position. And a lot of people will just leave that blank. They'll write 6x cubed times 2x squared. And that can't be right, because 6x cubed times 2x squared only gives me the 12x to the 5th. I would lose the minus 6x cubed. So that's going to happen sometimes. Sometimes you're just going to need to fill in with a 1. If you factored out an entire term, you have just a 1 left over. Questions on that one? Last thing I need to do. Minus 2x squared plus 24x minus 72. All right, so you'll notice this is similar to problems we did before in the sense that it has a trinomial. It's got 3 pieces. What's the big difference between this one and all the other ones we did? It's got a number in front here. Okay? So what you want to do, anytime you go to factor, the very first thing you should always look for when you go to factor is a greatest common term. Is there anything common to all 3 of those pieces? A 2. In fact, I'm going to take out a minus 2. Because I like to have just x squared there. I don't even want the minus sign there. So if this is a negative out front, I'm generally going to factor out a negative. So I'm going to have a negative 2, and then I'm going to have x squared. What's the next piece going to be?
Plus negative 12.
Minus 12x, because negative 2 times negative 12 gives me the positive 24. And then finally, plus 36. Okay, so at this point in your life, if you have a trinomial and the trinomial has a common factor, you factor out the common term like we did. But then what you need to do, you need to look to see if this trinomial will factor more. And what I mean by that is we could have the negative 2 and then 2 sets of parentheses like that. Sometimes it'll work, sometimes it won't. You don't know until you try it. It's got to be x and x in front to give me the x squared. Negative 6 and negative 6. I agree. I think negative 6 and negative 6 will work. How come negative 6 and negative 6 will work? If you add them, negative 6 plus negative 6 gives the negative 12 in the middle. And if you multiply them, negative 6 times negative 6 gives positive 36. So there's our answer. So sometimes you're going to have to factor more than once. And this is a good example. We had to start by factoring out the greatest common factor, the negative 2. And then once we factored out the negative 2, we noticed we still had a trinomial left over. We needed to factor that. Questions on that?
So that's pretty much everything we did today combined.
That's pretty much everything we did today combined into one question. That's correct.